How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for real gases and deviations from ideal gas behavior. All right, so this van der Waals equation is going to be kind of at the root of it, right? So let's take a look at some of them. Molecules of an ideal gas differ from a real gas in that ideal gas molecules, well, let's see. Ideal gas molecules have a molecular weight of 0. That is not true. All right, ideal gas molecules have an average molecular mass, but I mean, that's true for both of them. All right, so that's, I don't know, that's not really a difference. Ideal gas molecules have no attraction for one another. That is a true statement for ideal gases. We would say they're not attracted to each other, but real gases are, so that is a difference. Ideal gases have no kinetic energy. That doesn't make any sense. Of course they do. Or ideal gas molecules have appreciable molecular volumes. No, this is true for real gases. Right? Ideal gases, we say the volume of the molecules are negligible, we ignore them. So the best answer will be choice C. Number 2, when a real gas behaves, or when will a real gas behave the most like an ideal gas? So gases, we know they like to spread out. So that means we want a low pressure. That'll let them spread out the most, and they have lots of energy. So that means we're looking for high temperature. So high temperature, low pressure, a gas will be the most gas-like. So which one of these we got? High temperature and low pressure, boom, choice B. All right, number 3, which of the following gases would behave the most ideal? So we want small and nonpolar, right? We want the weakest attractive forces, which means we want a nonpolar molecule, and it's got to be the smallest. So if I'm taking a look, CH3Cl, well, I can rule that out. That's a polar thing. The rest of these are nonpolar. So if I take a look at the masses, F2 is going to be 38, krypton is going to be 84, CO2 is going to be roughly 44 grams per mole, and neon is going to be roughly 20 grams per mole. So the lightest one that is also nonpolar will be neon. Neon is going to be the most ideal. Right, number 4, the van der Waals equation for real gases accounts for the fact that what? Let's see. Pressure exerted by a gas is decreased by the molecular attractions between the particles. That is a true statement, right? So these particles are attracted to each other, which means they don't fly off and bump into the walls with as much energy as an ideal gas would. Let's see. Accounts for the fact that molar volumes of gases of different types are different. That is true. Some gas molecules are bigger than others, and the van der Waals equation accounts for that. What about this? The gas particles have a non-zero volume, which effectively decreases the amount of empty space between them. That is also true, right? Ideal gases, we say they're so small we ignore them, but in reality, they're bigger and they take up space, which means there's less empty space between them. All right, what about D? Gas particles have non-zero volumes and interact with each other. Yeah, it counts for that. So choice E, all of the above. The van der Waals equation accounts for all of those things. All right, number 5, when gases are treated as real gases and not ideal gases via use of the van der Waals equation, the actual volume occupied by gas molecules will increases, right? Those gas molecules actually take up space. So when we account for that, the volume they occupy goes up. The pressure exerted and the attractive forces between the gas molecules decreases. Right, so the pressure goes down because those molecules are attracted to each other, which means they're not flying off with as much energy. So reading this full, when gases are treated as real gases and not ideal gases, the actual volume occupied by gas molecules increases, and the pressure and the attractive forces between gas molecules decreases the pressure exerted as compared to an ideal gas. There you go. Hope you found it helpful. See you in class. Okay, bye.